In section 4B, we're going to talk about simple interest and compound interest and continuously compounded interest. To start off, we're going to look at simple interest and compound interest, and we're going to do an example where we look at the difference between the two. So what is simple interest? Well, simple interest, that is interest that's paid on the original investment and not on any interest. So in other words, what's going to happen is, let's say you put into a savings account $1,000 and you get simple interest of, let's say, 10%. So 10% of $1,000 is $100. And that would mean, let's say, after every year, you get 10% interest. So every year you'll get $100. So in your account you'd have $1,000, and at the end of the first year you'd have $1,100, and then at the end of the second year you'd have $1,200 because you have another 100 from the interest, and then the next year you'd have $1,300, and so on. So you're just adding the $100. That's the interest that you're gaining from that original investment of $1,000. Now, what is compound interest? So this is interest that's paid on the original investment and on any accumulated interest. So let's go back to that example of you putting $1,000 in your savings account. Well, let's assume that the savings account had 10% compounded interest, and it's compounded once a year. So what's going to happen is you put $1,000 in your savings account. At the end of the year, you'd have $1,100, just like you did with the simple interest. Then the next year, you wouldn't have $1,200 in the savings account. You'd have $1,200 plus a little extra. And that's because when they calculate the interest that you're going to receive, you're not only getting the interest on the $1,000, but also the $100 that was added to the account. So you're going to get, I think you're going to get $1,210 instead of $1,200 because you're going to get a little bit extra from the interest that's in the account. We're going to look at an example in a minute where we're going to see the differences. Like, we're going to actually write an example down. So there's going to be a formula for the simple interest and for compounded interest. Let's talk about the simple interest first. So this formula is A is equal to P times 1 plus RT. So P is going to be your principal. And what I mean by principal is that's your investment, what you're going to put into your savings account, your starting point. R, which we also will see as APR, is going to be your annual percentage rate. So how much you're going to be getting for interest, like the percentage. T is going to be time, and this is always going to be measured in years. Okay, if it's not given to you in years, you're going to have to convert it to years. And then the last letter is this A, which A is going to be your accumulated balance. So in that example we were talking about just a minute ago, the principal, what you invested was the $1,000. So you'd put it here, $1,000. And the rate was 10%. So we would put 0.1 here. You have to convert it to a decimal. So let's put that here. We're going to write as a decimal in order for this to work. And depending on how long you want, like if you wanted to know how much money you would have at the end of 2 years, your T would be 2. And then you'd plug all that in the calculator and you'd figure out how much money you would have after 2 years. So in our example, it would have been $1,200. So that's what you would get for A. Now, compound interest is more complicated. We're going to write down the formula and then we're going to do a problem with it. So right now we're just writing down the formula. So the compound interest formula is A is P. It's going to look similar in the beginning. It's 1 plus R over N raised to the NT. Now this is an R, so let me make it a little easier to see. And let me write all these letters out. Now the only new letter, all these letters are going to be the same except for this N. This N is something different. So P is still going to be the principal. That's what you're going to put in. R is still going to be your APR, your rate, annual percentage rate. I don't want to write it all out again, so I'm just abbreviating it. T is your time, which is given in years. So we got PRT. We're going to say A is the accumulated balance. And the last one, N, is the number of times you compound. So I'm going to put on the side some common N's. So in your problem, you're going to see something like compounded annually. So that means you're going to be getting interest once a year. So N is going to be 1. If you see in your problem compounded semi-annually, N is going to be 2. That means twice a year. If you see compounded quarterly, well, there's 4 quarters in a dollar, right? N is going to be 4. If you see compounded monthly, I guess you could probably guess what this is. N is going to be 12. And the other one you might see is compounded daily. N is going to be 365. This is just telling you how many times a year you're going to be getting interest in your account. Okay, so that's a lot of information at once. It's a big formula, we haven't even used it. So let's do one example just to get our feet wet with this type of information here. So what I want to do is just see the difference between the simple interest formula and the compounded interest formula. So here's the problem. Todd deposits $5,000 in an account that earns simple interest at an annual rate of 3%. Okay, Tony deposits the same amount, $5,000, into an account that earns compound interest and at the same rate. So Todd and Tony are both depositing $5,000. So I'm going to put Todd here. I'm going to put Tony here. And their investment is the same amount, $5,000. They have the same APR, the annual percentage rate. So their APR is 3% for both of them. What I want to do is I want to compare, now this isn't written here, but I want to compare the balance in both accounts. Let's say after 1, 2, and 3 years. So let's see the difference. What's going to happen that's different? So Todd, by the way, he has simple interest. So I'm going to circle that and I'm going to put this here. This is simple interest. And Tony, his earns compound interest. So that's the only difference between these two problems here, these two guys and their accounts. All right, let's do Todd first. His is the easiest one. So I'm going to put after 1 year. Let's pull this little line down. After 2 years. And then I'm going to put after 3 years. I'm going to look at how much money he has in the account each time. So the formula for the simple interest, let's put that formula right here. It is A is P1 plus RT. So what you're going to do to figure out how much money he has after 1 year, you're going to say A, because that's what we're looking for. The accumulated balance is P. P is our investment, which is $5,000, times 1 plus the rate, but you're going to write the rate as a decimal, 0.03, times the time in years. And there's only been 1 year, so we're just going to put in the calculator 5,000 times 1.03. So let's see what that is. Here I have a calculator. Put 5,000 times 1.03. $5,150. So let's write that. So what's happened here? He has $5,000 in the account. That's what he invested. He's going to earn interest. The interest is 3%. So 5,000 times 0.03 is $150. So 3% interest, he's going to gain $150. So this $150 is on top of the $5,000 that's already in the account. So he's going to have $5,000 in the account plus this 3%. And this one here is to let us know that we need to keep the $5,000, because if we just put the 0.03, we just get the $150, but we're going to have the $5,000 and $150. So 3% interest is $150 for $5,000. So how much would he have after 2 years? Now you don't need the formula to figure this out, but we're going to use the formula to figure it out. But we can just go ahead and say what it's going to be, because if it's $150 interest each year, then after 2 years he'll have $5,300. But let's put it in the formula to double check. So this is 5,000, 1 plus 0.03 times 2, because it's 2 years. Still the same principal, still the same rate. So this is going to be 5,000 times 1 plus, what's 0.03 times 2? It's 0.06. So it's going to be 1 plus 0.06, which is 1.06. So if we put that in the calculator, 5,000 times 1.06, we get 5,300, which is what we expect because he earns another $150 after year 1. So for year 3, we expect him to have $5,450. Let's see. A is 5,000 times 1 plus 0.03 times 3, because we have 3 years. So this is going to be 5,000 times 1.09. 0.03 times 3 is 0.09. Add 1 to it. So let's put 5,000 times 1.09. 5,450. Exactly what we expected to happen. Now let's compare this to the compound interest formula. So I'm going to put the compound interest formula here. A is P 1 plus R over N to the NT. Okay. In this problem, he's going to get his interest annually, just once a year. So for our problem, N is 1. And how we know this is because it says annually. Usually it'll say compounded annually. For this problem, it's just saying annually and doesn't have that information. So we're assuming that it's once a year. In other words, they're only adding interest to Tony's account once a year. Okay, let's figure out how much money he'll have at the end of 1 year. So after 1 year, and I'm going to circle this. So I'm going to plug all my information into this formula. So A is P, which is 5,000. 1 plus my R, 0.03, divided by my N, which is just 1, raised to the N times T. So 1 for N is 1, and 1 for 1 year. So this is N and this is T. We can simplify this. This is 5,000, 1 plus 0.03, because it's just divided by 1, raised to the 1. Notice that this formula right here is the same as this one. You see? So what is that? If we put it in the calculator, 5,000 times 1.03. $5,150. So what has happened is he's earned interest of $150. There was $5,000 in the account. He gets 3% interest, so he gets $150 extra in the account. So the first year is going to be the same as the original first year with simple interest. It's after year 1 where things become a little bit different. So after 2 years, let's plug this into the calculator. Now, the hardest part of this problem is plugging it into the calculator. If you have problems with this, you should let me know. You just have to be careful with how you plug it in. You should do a few problems, make sure you can get the same answer. And watch how I plug it in the calculator. So after 2 years, we get A is 5,000, 1 plus, okay, R over N, R and N don't change, raised to the N times T. This time T is 2. So all of this simplifies to 5,000, 1.03 squared, because 1 times 2 is 2. Let's put it in the calculator. 5,000 times 1.03. Now we have to square this. So I'm going to hit Shift 6, because this is a little caret key, to get this 2 on the top. But I think you can hit this button too. And on the calculator, you're going to have something that, let me write it down so you know. If you want to go into the power, you've got to hit this button that looks like a little, they call it the caret key. If you find it, that'll push you up. So you could put 1.03 up to. Okay, so let's hit enter. We get 5,304.5. Let's write that down. something happened here, because after 1 year we got the same amount. You see 5,150, 5,150. The second year we got $4 more than what we got with the other one. We had 5,300. We have 5,304. So why is this? Why did we get extra? And I'm going to tell you why. So now we have $5,150 in account after 1 year. So what is happening here is we're going to take that 5,150 and we're going to get interest on that whole total. So with the simple interest, we were only getting interest on the 5,000, but we're putting extra money into the savings account. So we want to get interest not only on the 5,000, but also on the $150. So if we take 5,150, multiply it by 0.03, we get 154.5. So we have the original $5,150 in the account, plus this $150 from the $5,000 we get in interest, and then this extra $4 because we get that extra $4 from earning interest on the $150 that we put in the account. So then that, if you add these together, gives you 5,304.5. I hope that makes sense. So let me just repeat one more time. Here, in this example, we're only getting $150 each year. Even though we have more money in the account, the $150 is only going towards the original investment. So each time we add $150 because we're gaining interest on that original investment. With compound interest, you gain money on the original investment plus anything extra that's in the account in that year. So the first time we only had $5,000 in the account, so we got $150 as interest. After the second year, we had not only $5,000 in the account, we had $5,150. So we're getting interest on that total. So it's going to be a little bit extra because of the extra $150. So let's do one more year. I'm going to do it over here. So after 3 years, remember our formula looks like this. Here n is always going to be 1. Our rate is 0.03. T though is going to be 3, and our starting principal is $5,000. So A is 5,000. 1 plus 0.03 divided by 1 raised to the 1 times t, which is 3. So it's $5,000 times 1.03 cubed. Put that in the calculator. 1.03 cubed. And then multiply that by 5,000. We get 5463.64. So as you can see, 3 years with the simple interest, it was 5,450. 3 years with the simple interest is 5,463. So we earned $13 extra. And that's because in our account, after the second year, we had this amount, 5304.5. So we add interest to this whole amount. You take 3% of this and add it to this number because this is the amount in the account. Then 3% would be the interest, and if we add it to this number, we get this one.